Hello. In this lecture, I try to clarify the probability distribution functions, and there are a number of lectures in this series. So this is the first part, and in this lecture, I try to clarify what is the probability and what is and why the probability is so important in our life. Okay, so look, our life is full of is filled with some uncertainties, and there are a number of chances in our life. So if you take an example, what is the chance that your motorcycle will be pulled away if you park illegally? If you park illegally, what what is the chance? What is the chance that your motorcycle will be pulled away? Another example you can take, that is, what are the chances you will get a 3 on the first roll of the dice? And what are the chances you will get hit of the first flip of coin? So these are the uncertainties. And probability, here is the role of the probability. Probability actually deals with the uncertainties. And and here the probabilities are quite effective to deal with uncertainties. In simple, we can say that it is a that numerical measure of chance or likelihood that a particular event will occur. That a particular event will occur. It is the probability. That is, in simple, you can say it is a numerical measure of chance, numerical measure of likelihood that a particular event will occur. Now, now look, the value of probability lies between 0 and 1. When it is 0, the probability is 0, it indicates that an event is very unlikely to occur. There is no chance of happening the particular event. A probability near 1 indicates that an event is almost certain to occur. That is, it is certain of happening a particular event. So other possibilities between 0 and 1 represent varying degrees of likelihood or chance that an event will occur. If you see this, if you see this pictorial presentation, then when it is zero, that is, probability is near zero, it indicates that an event is very unlikely to occur. And here the event is almost certain to occur when the probability is 1. And when it is zero point 0.5, the occurrence of the event is just as likely as it's unlikely. 50% chance of happening, 50% chance of not happening. And a journey from 0 to 1 represents increasing likelihood, increasing chance. Okay. So some important terminology are there, and you should have and clear. You should have a clear idea over these concepts. So, what is the random experiment? Random experiment are those experiments whose results depend on chance. When you flip a coin, then head will appear and tail will appear. It depends on chance. Head may appear, tail may appear when you flip a coin. So flipping a coin or tossing a coin is a random experiment. Now the concept outcome. The result of a random experiment, that is, when you toss a coin, then head may appear or tail may appear. And this head is an outcome and this tail is an outcome. So, the results of a random experiment is outcome. Now the event. It is used to denote any phenomena which occurs in a random experiment. When you toss a coin, then head may appear or tail may appear. This head is an elementary event and this tail is a elementary event. But when you toss two coins at a time, then head may appear, and this head will be composite event. Sorry, it is elementary event. When you toss a coin, when you toss two coins at a time, and head and tail will appear, then this head and tail is a composite event because you can decompose it in simpler way. You can decompose it HT, head and tail. You can decompose it. So it is a composite event. And HH, that is when you toss two coins at a time, HH will appear, and this HH is an elementary event. Now, mutually exclusive, when two or more events cannot occur only one at a time. When two or more events cannot occur only one at a time. Mutually exclusive. When you toss a coin, head may appear or tail may appear. So tossing a coin, this head or tail are mutually exclusive. Are mutually exclusive. Two cannot occur at a time. Now exhaustive, if at least one of the events must necessarily occur, then the event is exhaustive. When you toss a coin, then head or tail definitely will occur. One must occur. One of the events, that head or tail must occur. So here the events are exhaustive. Now equally likely, none of the outcomes of a random experiment can be expected in preference to other. Then you can call it equally likely. When you flip a coin, you cannot expect what will happen, head or tail. You cannot prefer one. You cannot prefer head. You cannot prefer tail. So none of the outcomes when you toss a coin can be expected in preference to other. You cannot expect head or tail. You cannot expect tail. So these outcomes are equally likely. Now, the classical view of probability. There are a number of views of probability. The first is the classical view of probability. It is a theoretical number defined as ratio of the number of favorable cases to the total number of possible cases. Suppose you toss a coin and you are getting hit, then the favorable case is 1 and total number of cases is 2. So 1 by 2 is the probability as the classical view of probability is concerned. Happening of hate is the favorable case here and total number is 2. Now, the frequency view of probability. It is nothing but the relative frequency. It is nothing but the relative frequency. If you flip 3 coins at a time, then total outcomes will be 8 and getting of one head is 1 by 8. Is 1 by 8. This is the relative frequency. This is the relative frequency. So relative frequency, so the frequency view of probability is nothing but the relative frequency. Now, the subjective view of probability, it is based on personal belief. It is based on personal beliefs. Subjective probability is a type of probability derived from an individual's personal judgment about whether a specific outcome is likely to occur. Suppose there is a there is a there is a tournament. Suppose there is a tournament between England and India. There is a cricket tournament, and if you ask a fan of India, then the if you ask the fan who will win the match, then the fan will say that 20% chance of winning. India has 20% chance, 25% chance, suppose 25% chance, 25% chance of winning the tournament. So here the subjective probability is applicable because personal judgment is applied here. There is no calculation, no mathematics. So subjective view of probability is a type of probability derived from an individual's personal judgment about whether a specific outcome is likely to occur. Now, random variable. Variable whose value is determined by a random experiment is called the random variable. Consider the experiment that consists of tossing a coin twice. Head indicates H, tail indicating T. Then the sample space for these experiments is this: head, 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 tail, tail, head, tail, tail. Suppose we let X is the number of heads occurring on the two coin tosses. X is the number of heads occurring on the two coin tosses, then the X is a random variable. X is a random variable. The numerical description of the experimental outcome can assume values here 2, 1, 1 and 0. That is 0, 1, 2 are the values of X of occurring of the heads of occurring heads on the two coin tosses. So random variable here in my example, the random variable is the number of heads occurring on the two coin tosses. And here the number is 0, 1, 0, 1 and 2. So the variable whose value is determined by a random experiment is called a random variable. Now, the probability distribution. It is a table or formula that lists the possibilities for each outcome of the random variable X. Probability distribution is nothing but a table that lists the possibilities for each outcome of the random variable x. Look at this. If you flip 3 coins at a time, then the probability of getting heads can be presented in the following table. This table. Okay, look at this table. You are flipping 3 coins at a time. Then head, head, and head will appear. So here 3. Head, head, tail may appear. So here 2. Head, tail, head may appear. It is here 2. Head, tail, tail. It is 1. Tail, head, head. It is 2. Tail, head, tail. It is 1. Tail, tail, head. It is 1. And tail, tail, tail. It is 0. Because this represents the probability of getting heads. Probability of getting heads. So here the number of outcomes are 8. Number of outcomes are 8. 1, 2, 3, 4, 5, 6, 7, 8. So if you flip 3 coins at a time, then the number of outcomes are 8. So now here the outcome of random experiment, here the probability of getting heads is the probability of getting heads. That is the random variable. That the random variable is the getting head. Number of heads occurring on the 3 coin tosses. So here what is the random variable? Here the random variable is the number of heads occurring on the 3 coin tosses. So outcome of random experiment is represented in this table. 0, 1, 2, 3. And now 0, 0, 1, 2, 3. So here 1, you can find 1, it means 1 getting hit. The number is 1 of you are getting hit one time. You are getting hit one time. 1, 2, 3. Okay, 3, 3. This is the favorable case, and 8, the total number of outcome. Okay, total number. So this is the relative frequency. This is the relative frequency. Probability of getting two heads. 1, 2, 3. So 3 by 8. Probability of getting 3 heads at a time. So 1. So 1 by 8. Probability of getting no heads. That is 1 by 8. If you sum all these 4, then you get 1. This must happen. Okay, this must happen. So this is the distribution or spread of the probability. So in this lecture, I try to clarify what is the probability and what is the classical view of probability, what is the frequency view of probability, what is the subjective view of probability, and also some important terminology I have tried to clear in this lecture. And what is the probability distribution, what is the random variable. I hope you can get the clear concept in this lecture. Thank you for enjoying this.